ಎಲ್ಲರಿಗೂ ನಮಸ್ಕಾರ. ನನ್ನ ಹೆಸರು ಚಂದನ್ ಎಂಜೆ, ವರ್ಕಿಂಗ್ ಆಸ್ ಲೆಕ್ಚರರ್, ಡಿಪಾರ್ಟ್ಮೆಂಟ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಿಕಲ್ ಆ್ಯಂಡ್ ಎಲೆಕ್ಟ್ರಾನಿಕ್ಸ್ ಇಂಜಿನಿಯರಿಂಗ್, ಗೌರ್ಮೆಂಟ್ ಪಾಲಿಟೆಕ್ನಿಕ್, ಕಾರವಾರ. ವೆಲ್ಕಮ್ ಟು ಸೆಷನ್ 4 on Unit 4 Power Installations of Subject Electrical Estimation and Costing, 5th semester, with subject code 15EE54T. The topics covered in this session: draw the single line diagram of power distribution scheme showing grading, discrimination of rating of protective devices. As in the previous sessions, we have discussed how to draw the single layout diagram of a workshop and how to install the machines and where to place the machines, what are the standard space or standard IS standards space must be provided for installation of machine, and how to draw the wiring plan of a given workshop, and how to select the protective devices or equipments, like how to select the starter, and how to select the MCB, and how to select the ELCB, and how to select the cable, and how to select the different rating of capacitors. Everything we have discussed in the last sessions. Okay, so and here we in this session we are going to discuss about the single line diagram of a power distribution scheme showing grading or discrimination of protective devices or and here in this session, so it means what are the equipments we have selected, we are keeping in a order, how to place these equipments which we are going to discuss in this session. So the power installation, generally we use surface conduit system is preferred. Okay, the energy meter is placed at the accessible and maintenance free location. Okay, we have placed the energy meter near to the entrance so that it should be accessible, right? So the main board is maintained by consumer, and this panel board consists of minimum accessories or main switch, either it may be ICTP or it may be DP switch, so and fuse kit and indicators for each phases, that is R, Y, B. For 3 phases we use 3 neon indicators, and ELCB, so that is earth leakage circuit breaker, and MCBs we use, and sufficient load carrying capacity conductors we are used for the connection of motors. Okay, so next, the sub-circuit board, or you can call it as individual machine board, which consists of the following equipments. So that is sufficient load carrying capacity main switch, so that is it may be ICTP or ICDP switches we are using, correct rated capacitors, so the power capacitors which we are using for the correction of power factor or to improve the power factors, and a suitable starter with suitable relay range current which is required for our motor starting. Okay, so these equipments are installed near to the every machine's board. Okay, so which is installed in the machine starter board, you can call it as a starter board of the individual machine, and that starter board is installed near to the individual machines. Okay, and these electrical equipments such as metal parts of panel board and all the starter board metal parts, everything must be earthed, and motor body is also must be earthed. Okay, so these are the general procedures we are following while doing the power installation. So then let's see the single line diagram of power distribution in a large factory. So this figure represents the power distribution single line diagram for a large factory. So you can see here the supply from the pole is taken, so that is mains, and it has given to the energy meter, and after that so it has taken to the main switchboard, and in the main switchboard we are having so some different switches like ICTP with fuse unit we are using. See, you can see here switch fuse units, these are the fuse units, and these are the switches like ICTP and all. Okay, and here so in the main switchboard, so only for the 2 switches we have taken the connection, and another 2 we have kept it as a spare, so this may be used for future connection, or if any problem happens this switch, then you can take over those load to this switch. Okay, so this may be future expansion of the factory, or for the standby operation we are using this spares. Okay, and from this main switchboard, so we are given to the sub switchboard. Okay, so in the previous case, in the small factories, what we are doing, from the main switchboard itself we are taken to the starter board, but here it is a very large factory, consists of so many machines, so we are dividing the circuit. Okay, so from the main switchboard we are taken to the sub switchboard. So here there are two sub switchboards, you can see here, sub switchboard 1 and sub switchboard 2. Okay, so and in the sub switchboard also we are using sub switches as well as fuses. Okay, so here there are number of 5 number of switches, ICTP or ICDP, so depends on whether it is a 3-phase or it is a single phase. So now we are using along with the switches we are using the MCB as well as fuse units. Okay, so you can see here, and in the sub switch ports we have made a provision for 5 connections. In that only 3 we have used and 2 we have kept it as a spare. Okay, so next, so here in the sub switchboard, one circuit goes to the distribution board. Again we have taken it to the distribution board, and from the distribution board it goes to the machine through the starter board of this individual machines. Okay, so here we are having some distribution board 1, distribution board 2, distribution board 3 and distribution board 4. Okay, so here in the distribution board 1, so we have taken one supply or one connections, and it is given to the motor 1 through the starter board. In this starter board it consists of individual main switch and individual MCB and individual starter and individual capacitor. Like this, the second motor is consist of second motor board or motor starter board. So here this also consists of same exercise, like switchboard switches, switch of the machine and starter of the machine and capacitor bank and MCB and all same way. So from the distribution board 1 to the machine 3, connection is taken through the starter of the machine 3. Okay, and the spare is provided for future installation of the machine or for the standby operation. Okay, and in the same way in the distribution board we have taken as a connection for the motor 4, motor 5 and motor 6, and here also we have provided one spare. Okay, for the standby operation. And from the distribution board 3, same, we have taken connection to the motor 7 and to the motor 8 through the individual respective starters, and we have provided 2 spare here. Okay, and when you come to the sub switchboard 2, from the sub switchboard 2 we have taken supply to the one distribution board, and so directly to 2 machine boards. Okay, so here you can see directly we have taken to the 2 machine boards through their individual starters, and we have kept 3 as a spare. Okay, here 3 switches or 3 connections we have reserved for future connection, or we can keep it as a spare or standby operation, you can call it. Okay, so from this sub switch board 2 to distribution board 4 we have taken. So and from the distribution board, so we have connected 3 motors to this distribution board 4 through the individual motors, and we have provided 1 spare for the future motor installation or any standby operation. So this represents the single line diagram of power distribution in a large factory, so which is having so n number of large number of machines. Like here we have provided 13 machines connection, and along with spares for the future expansion also. So this is how they have divided the circuits into different segments or sub circuits, and they connect it to the individual machine through the individual switchboards or starter boards. Okay, so here we have shown only the power circuit diagram. So this factory may also consist, in the same way it may also consist of lighting circuit diagram. Okay, so because any factories, as we have discussed, the lighting installation has to be provided, so that to achieve the sufficient illumination, so that workers can work properly in the factory. Okay, so that lighting circuit we have not shown here. Same way, from here only you can take the separate lighting circuit, and the same way you can divide as a sub circuit and distribution board for the lighting circuit in the factory. Okay, so this is one example. So this is another example which you can see here. So for here we have taken the single phase supply. So the power from the pole is taken and it is given to the single phase energy meter, and from that we have given to the distribution board. Okay, so in the distribution board the power is distributed for the individual machine. See here we have connected 4 machines. So that is called as subcircuit 1, subcircuit 2, subcircuit 3, subcircuit 4, subcircuit 5, subcircuit 6, subcircuit 7 and subcircuit 8. Okay, here subcircuit 1, subcircuit 2, subcircuit 3, subcircuit 4 are connected to the machines. So there are 4 machines you can connect. So 1 machine, 2 machine, 3 machine, 4 motors. Okay, 4 machines or motors you can call. So another 4 circuits which we are using for lighting purpose, lighting of the factory purpose we are using, right? And individual machine is provided with MCBs and switches. Okay, so if it is since it is a single phase supply we have taken, we are using DP switches, and one more main DP switch which you have placed in the main board itself. See, this is one DP switch, and also we are provided with ELCB, earth leakage circuit breaker, with a tripping current of 30 milliampere, and the main rating of this DP switch ELCB is 63 ampere, and the main rating of this DP and MCB is 63 ampere. Okay, so here 4 circuit is for power wiring, so that is for motor installation. Another 4 sub circuit for lighting installation is provided, and individual sub circuit is provided with individual MCB and SP switches is shown here. Okay, so and each motor is provided with individual starters, so that are placed in the starter board of individual machine. So this is the example of single line diagram in case of single phase supply. Okay, this is used usually in the small factory you can call. So this is one more example of a single line diagram of one machine connected to the mains. Okay, here we have only one motor, so that is to be connected to the supply. So here the supply is taken from the pole and it is given to the main board. In the main board you have indicators and energy meter and main switch. So you can see this main switch and main fuse unit and main MCB. From there you have taken supply, so that is 3 wire plus earth wire we will take, and it is given to the motor switch board or motor starter board. In the motor starter board, what it consists of? It consists of individual ICTP and individual MCB and starter and capacitor bank. Okay, and here since it is a HP of the motor maybe more, so we are using star delta starter here shown here. Okay, from star delta starter, so to the motor we will connect the terminals of the motor by using how many wires we required here? 6 wires plus earthing wire is required. So you must remember we have already discussed this topic. So from the starter board of the star delta starter to the machine terminals, we required 6 cables for the connection purpose. Okay, and the size of the cable may be reduced because the phase current of the delta is √3 times less than the line current, right? Hence the size of the cable from your starter board to the motor is less than what is the cable here you required. Okay, here we use only 3 cables or 3 wires from your main switchboard to the starter board of the individual machine, and after the star delta starter, so then we required 6 wires from your starter board to the motor terminals. Okay, so this is how to draw the single line diagram of one motor is given. Okay, so next let's see some other examples here. So here you can see here, so this is one more example of single line diagram. The factory consists of 5 machines of different rating. So these 4 motors have provided with the DOL starter, since this 4 motors are small rating, and this is provided with star delta starter. This symbol represents star delta starter, hence this motor rating is very high, 7.5 kilowatt. So here, so you have taken the 3-phase supply and it is given to this main board. So in the main board you might having a energy meter and main ICTP switch and ELCB and MCB and indicators, and after that it is given to the individual switchboards. Okay, so in this individual switchboard it consists of individual switch, So that is ICTP of individual rating, and MCB and capacitor bank and starter, and from the starter it is connected to the individual motor terminal. So this is about motor 1, and here in the motor 1 we are using star delta starter, and in the motor 2 same case. Motor 2 from the main board to the motor 2 switchboard we will take the supply, and in the motor 2 we are having ICTP, MCB and power capacitor and starter. Here the motor rating is very small, we are using DOL starter. So from the DOL starter the cables are connected to the terminals of the motor. And here also same case in case of motor 3 also. From the main board the supply is taken to the motor 3 starter board, and in the starter we use individual ICTP and MCB and power capacitor and a starter, DOL starter. So and from the DOL starter terminals to the motor we will connect the cable. Same case in case of motor 4 and motor 5 also. Here every part of non-conducting part of this motor terminals or body of the starter and body of the energy meter and body of the panel board, everything must be connected to the earth by using earth wire. Okay, so this is how to draw the single line diagram of a small factory given. See here you can see here small in the small they have written small character. So that is the length of the cable. What is the length of the cable required from your starter board to the motor? So and everything is written from the distribution board or main board to the individual starter board. What is the length required, and what is the current capacity of this switch is required, and what is the current capacity of the starter is required, relay current capacity of the starter is required, and what is the power factor of this individual motors is required. Individual motor is, everything has been written in this diagram. And this is also one more example you can see here clearly. So this is a small workshop, consists of one milling machine, two lathes and one grinding machine and one drilling machine. Okay, so here the supply is taken from the source, so through service mains, and it is connected to the main board, or you can call it as main bus bar. And in the main board we are having energy meter and main switch and indicators and main MCB and ELCB, and from that main board we have taken to the individual starter board, and the individual starter board from the individual starter board we are giving connection to the individual motor terminals. Okay, and a different length of the cable is required, depends on the location of your motors. So this is how to draw the single line diagram of a small factory as well as large factory, and how to draw the ratings of individual protective equipments. The ratings of individual protective equipments and main protective equipments depends on the load, so depends on the number of machines you have installed and the rating of each machines. Okay, so that is how to draw the single line diagram. So let's see some MCQs on this session. Let's take the first MCQ. For 10 HP motor, star delta starter is used. How many leads or cables is required to connect starter to the motor? Here options are A 3, B 4 cables, C 5 cables, D 6 cables, or 6 wires you can call. Cables means wires or conductor. So here you are having 10 HP motor and you are using star delta starter. And how many cables or wires required to connect the starter to the motor terminals? Here you are using star delta starter. Okay, so the answer is D 6 cables. As we have discussed, there are 6 wires required to connect the star delta starter to the motor terminals. Okay, so next question you can see, for 3 HP motor, DOL starter is used. How many leads or wires or cables is used to connect the starter to the motor? Option is A 3, B 4, C 5, D 6. So here the motor is 3 HP motor and we are using DOL starter. Then how many cables you required for the connection of your DOL starter to the motor terminals? hence it is a devoid starter. We use only 3 cables, so the answer is A, 3 cables. Okay, so and we have a next question. So which of these electrical elements must be earthed? Panel board, option A panel board, option B motor body, option C starter body, option D all the above. As we have discussed, as you know, the panel board also must be earthed, and motor body is also to be earthed, and starter body and any starter board body and everything has to be connected to the earth, right? Not only panel board, not only motor body, not only starter body, all the equipments, motor body, main panel board body, and a starter board body, and a starter body, everything has to be connected to the earth, right? So what is the answer for this question? So that is answer option D, all the above. Okay, so these are the some MCQs on this session. So these are the references books which we are referring for this subject, electrical estimation and casting of you have subject code 15EE54T. so you can refer these books and you can get the things. Thank you everyone.